Hello and welcome back. I'm assuming you have already watched video number 20. If not, please do so before continuing here, okay? Great. Today we're going to study 3 more types of unique rectangles, or URs, namely type 3, type 6, and type 7. But we're going to look at them in reverse order. Reason being, type 6 will be easier to understand after you understand type 7, and type 3 is unlike all the others, so we'll save that one for last, okay? So first, let's take a look at type 7, which are also known as hidden rectangles. Hidden rectangles, along with UR type 4, are probably the 2 most common UR patterns you will find in puzzles of any difficulty level. So you really need to master both of them. Now what you want to look for is a UR pattern with either 2 diagonal cells or any 3 cells with arbitrary additional candidates. If there is only 1 cell with additional candidates, then you should simply use type 1. And if there are 2 non-diagonal cells with additional candidates, then you should use type 4. And if all 4 cells have additional candidates, then there is no UR pattern. So when you see that you have 2 diagonal cells or any 3 cells with arbitrary additional candidates, pick one of the cells that contains only the UR candidates, like this one right here. Then direct your focus to the UR cell located diagonally opposite to that first cell, this one right there. This diagonally opposite cell is the cell where a candidate elimination may be possible, if at all. Next, check the row and the column containing this opposite corner cell and see if either UR candidate occurs outside that cell. If just one of them occurs outside that cell, then you can remove that candidate from that cell. Like here in this diagram, because the 6 occurs in the column and the row containing the red cell, you can eliminate the 6 from that red cell. First, let me show you how this works, and then I will explain why it works. Here in this diagram, the UR candidates are 6 and 9. R3C1 is a pure bi-value cell containing only the UR candidates, and we start with this cell. Now look at the diagonally opposite corner cell, which is R6C3, and this is the cell where a candidate elimination may be possible. So now we look at the row and the column containing that red cell, which is row 6 and column 3. And we look to see if any of the UR candidates are in either that row or that column. And we see that candidate 6 is there, but candidate 9 does not appear anywhere outside the UR pattern in row 6 or column 3. So that means you can eliminate candidate 6 from the red cell. Okay, so here's the logic behind this. Because candidate 9 does not appear anywhere else in row 6 or column 3, that means this is a conjugate pair. Those 2 9s are a conjugate pair in column 3, and those 2 9s are a conjugate pair in row 6 because they're the only 2 9s left in those 2 houses, okay? So if you solve this cell for 6, then that forces these 2 cells to be 9 because they're the only 2 9s left in that row and that column. So they would have to be 9, and then now you've got only a 6 left in this cell because that was a bi-value cell to begin with, and now you've got your forbidden pattern. So the red cell cannot contain candidate 6, and you can eliminate it just like that. Now the candidate only needs to appear once outside the cell in either the row or the column, and that is enough to make the elimination. And it can be anywhere in the row or the column, like it could be in here, down here, or here. It just needs to appear once. The key is that in order to make the candidate elimination, the other candidate cannot appear at all in either the row or the column outside the particular cell. And when you are checking the row and the column, as soon as you find a single instance of both UR candidates, then you can immediately stop looking and know that there is no elimination to be made. But if you find an instance of one of the candidates, then you must scour both the row and the column to make sure the other candidate is not there. 9 times out of 10 in a hidden rectangle, there will be just one cell with only the UR candidates like you see up there in row 3, column 1. This means that there will only be one cell to check, the cell in the diagonally opposite corner. And if there are 2 cells with additional candidates and they are non-diagonal, i.e. a row or a column, then just immediately look for a type 4. And if the 2 cells with extra candidates are on a diagonal, you can perform this technique twice, starting on each of the pure bi-value cells, like this. Okay, so here we have a rectangle and the UR candidates are 7 and 6. And we see that we have 2 of those cells have extra candidates and they lie on a diagonal. So we've got 2 bi-value cells and we can start on either one and do this twice. So let's start on this one up here, and then this will be our cell that we're going to check. So the first thing you do is you check in the row and the column to see if there's another candidate 7 or another candidate 6. Let's say there's a candidate 6 right there. That's actually all you need, but you still have to keep looking to see if there's a candidate 7. So let's say there's a candidate 6 up there, one here, and one there. And so we know that we can eliminate candidate 6 from that cell. Now let's go back. And if it were candidate 7 in any of those cells, in the row or the column, then candidate 7 would be the one you could eliminate from that cell. Okay? So now that you've done that, now we want to do it the other way. So put the 7 back in and get rid of these. Now we're going to switch. We're going to use this as our start cell, and now this is the cell we're going to check. And so let's say we see a 7 here, and a 7 here, and a 6 there, and a 6 there, and a 7 there, and a 7 there. Well, there's no elimination to be made now because both candidates exist outside the red cell in the column and the row. But as I said, while you're looking for those candidates, if you go across row 5 and you see 7, 7, 6, you go, well, both candidates are already outside that cell, so you don't even need to look in the column because it's not going to work. So in this case, we were able to make an elimination in this first cell down here, the green cell now, which was red. But we can't make an elimination in this red cell now because the 7 and the 6 occur outside that cell in both the row and the column. But it doesn't need to be both, just one or the other. You just need one of those candidates to exist in the row or the column outside that cell and the other one not to be there. Okay? Now, just like with the type 4, either one or the other or both candidates will occur outside that cell. It cannot be the case that neither will occur, because then you would have the forbidden pattern. And if both occur, like you see right here, then there's nothing you can do. But if only one of them occurs outside that cell, like for instance, let's say these 7s were not there, and it was just the 6s, then you can eliminate the 6 from that red cell. Okay, so here is the rule for type 7, known as a hidden rectangle. If either 2 diagonal or any 3 UR cells contain additional arbitrary candidates, then pick one cell containing only the UR candidates and then focus on the cell in the opposite diagonal corner. If only one of the 2 UR candidates appears in either the row or the column containing that cell, then that candidate can be eliminated from that cell. All right, let's take a look at some real examples. Here in this puzzle, the UR candidates are 4 and 8, and there is your rectangle. And we've got one pure bi-value cell down here, which is a requirement. You have to have at least one of those. And so the cell we want to focus on is up here, the diagonal corner. And now we look to see if candidate 4 or 8 appear in the row or the column containing that red cell. So we look down row 5 and we see there's a 4 here, and here, 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 and here. And now we look in column 2, and there's a 4 and a 4 and a 4 and a 4, but there are no 8s. So because there are no 8s, we know we can eliminate candidate 4 from that red cell, just like that. Got it? All right, next one. All right, here in this puzzle, the UR candidates are 7 and 6, and there's your rectangle. And this time we've got 2 cells with additional candidates and 2 bi-value cells. So we can apply the hidden rectangle technique twice on this configuration. So let's start on this cell up here and have this cell be our focus cell. So now we look in the row and the column containing that red cell, And we see that there is a 6 over here and there's a 6 here, but there are no 7s. So that means we can eliminate the 6 from that cell, okay? But let's put that back in here, and now let's switch. Let's have this be our start cell and this be our focus cell. So now we want to look for candidates 7 and 6 in row 2 and column 1. And in row 2, we see we've got a 7, and in column 1, we've got a 7 and a 6. So there is no elimination to be made here in this cell because both candidates 7 and 6 appear in the row and the column. So in this particular puzzle, all we can do is eliminate this candidate 6 and then we move on. All right? Okay, next one. All right, here in this puzzle, the UR candidates are 2 and 3, and there's your rectangle. And 2 and 3 appear in all 4 of those cells. So we've got one by value cell, which is normally the case with a hidden rectangle. And so our focus cell is going to be the opposite corner up here. So now we look in the row and the column containing that red cell to see if there is a 2 or a 3. And in the row, there's a 2 and a 2, and in the column, there's a 2. And that's it, there are no 3s. So that means we can eliminate the 2 out of that red cell because the 3 does not appear anywhere else in that row or column. All right, let's do one more. All right, this time the UR candidates are 2 and 5, and there's your rectangle. Forms a perfect square this time. The 2 and the 5 appear in all 4 of those cells, but we've got one by value cell. So our cell of focus is this one down in row 3, column 3. So now we examine the row and the column containing that red cell and look for candidates 2 and 5. So in the row, we've got a 5 and a 5 and a 5 outside the cell. And in the column, we've got a 5 and a 5 and a 5 and a 5 and a 5, but no 2s. So that means we can eliminate the 5 from that red cell. Okay, so that's a hidden rectangle, and we'll cover more of these in video number 21A. So let's move on to type 6 right now. A UR type 6 is the most productive UR of all, but unfortunately, they are very rare. You won't see many of these, but what's so cool about them is that whenever you find one, not only do you get to make 2 candidate eliminations, but you also get to solve 2 cells. It's pretty great, and here's how it works. At first glance, a type 6 looks like a hidden rectangle, the kind with 2 diagonal cells with extra candidates and 2 diagonal by value cells like you see here. But the difference is this. In a type 6, you have to look in both the rows and both the columns containing the UR. And if you see that one of the 2 UR candidates does not appear in any of those 4 houses outside the 4 UR cells, then you can immediately solve the 2 by value UR cells for that candidate. Here's why. The UR candidates here are 1 and 3, and they appear in all 4 of those yellow cells and form a rectangle. And we've got 2 diagonal cells with extra candidates and 2 diagonal cells that contain only the UR candidates. So now we look in both the columns and both the rows containing that UR and check to see if either candidate exists. And we see that the 1 appears in column 3, and the 1 appears in column 4, and there are no 3s. And then in row 4, there are 1s but no 3s, and in row 5, there are 1s but no 3s. So what's actually happening here is there is an X-wing on candidate 3, because they are the only 2 3s in row 4 and 5, and they are the only 2 3s in column 3 and 4. So with an X-wing, we know that one diagonal pair will be true and the other diagonal pair will be false, but we don't usually know which is which right away. But with a UR type 6, we do know, because these 2 candidate 3s cannot be true. And here's why. If you solve this cell for 3, that creates a naked single in these 2 cells, and now you have a hidden single up here, and that has to be the 3. So that can't be. There's your forbidden pattern. And likewise, if we do it the other way, if we solve this cell for 3, now you've got 2 naked singles here, and this becomes a hidden single. Remember, these were the only 2 3s in that row. Now that that one's gone, this has to be the solution. So there's your forbidden pattern again. So you know that these threes can be eliminated as false, but now what happens is the two blue threes are the only threes in those rows and those columns, and so they have to be the solutions to those cells because they become hidden singles. But you can save 2 steps by just immediately filling in those 2 blue threes because that automatically eliminates those 2 red threes. So when you have a UR type 6 like this and one of the candidates does not appear in any one of those 4 houses containing the UR cells, then you can solve the 2 bi-value cells for that candidate. Like that. Now don't confuse this with a type 4 or a type 7. With those 2 techniques, the candidate that appears outside the UR is the one that gets eliminated from the UR cells. But with a type 6, it is the candidate that does not appear outside the UR cells that gets eliminated from the 2 diagonal cells with extra candidates, which leads to placements in the 2 diagonal bi-value cells. Now those 4 cells don't have to be bunched together like that. They can be like this. All right, so here in this diagram, the UR candidates are 7 and 6, and they appear in all 4 of those yellow cells forming the rectangle. And we've got 2 bi-value cells on a diagonal, and we've got 2 cells with extra candidates on a diagonal. So now we look in both the rows and both the columns containing that rectangle to see what we've got. And in row 1, we see that there are 6s outside the UR, and in row 3, there are 6s outside the UR. And in column 2, we have some 6s down here, and in column 7, we have 6s down there. So that creates an X-wing on candidate 7. Like that. And because of what I explained earlier, we know that these 2 7s must be false. Because if we solve this cell for 7, it would create the forbidden pattern. Okay? And likewise, if we solve this cell for 7, it would also create the forbidden pattern. So they have to be false, which means you can immediately solve those 2 blue 7s for those 2 cells. Now, I'd like to point out another thing that's going on here. This is actually 2 hidden rectangles in one. We can look at this as here is our start cell and here is our cell of focus, and we see that candidate 6 lies outside that red cell in both the column and the row containing that red cell, so we know that we can eliminate candidate 6. And then we do it the opposite way with this is our start cell and this is our focus cell. Because the 6 appears outside the red cell in both row 3 and column 2, we know we can eliminate that 6 there. So what that does is that eliminates both those 6s and it solves those cells for 7. You get the exact same result, but by looking at this as a UR type 6, you can immediately solve those 7s in a much more efficient manner. Okay, so that's pretty straightforward, right? So let's go over the formal rule for type 6. If you have a UR that consists of 2 diagonal bi-value cells containing only the UR candidates and 2 diagonal cells containing additional candidates, if one of the UR candidates does not appear anywhere outside the 4 UR cells in the 2 rows and the 2 columns containing the UR, then the 2 bi-value cells can be immediately solved for that candidate. All right, so let's take a look at some real examples. All right, here in this puzzle, the UR candidates are 5 and 8, and there are your 2 diagonal bi-value cells, and there are your 2 diagonal cells with extra candidates. And there's the rectangle. So now what we want to do is we want to look in both rows and both columns to see if we can find either of those candidates. So we look in row 4 and we see there's a 5 and a 5 and a 5 and a 5. And in row 6 we've got a 5 and a 5. And then in column 2 we have a 5 and a 5 and a 5. And in column 9 we have a 5 and a 5. So the 5s are out there, but there are no 8s. So what this means is that there is an X-wing on 8. Okay? And because candidate 8 does not appear in any of those 4 houses containing the UR pattern, we know that the candidate 8s in the cells with the extra candidates are both false. So you can eliminate them one at a time if you want, or you can immediately solve those two cells for 8. Now let's go back to the original position, and let's get rid of the colors. And now I'm going to highlight the candidate 8s, and you'll see there's the X-wing. So you see there's an X-wing on 8, and there are no eliminations to be made, and that's what creates this pattern. All right, let's go to the next one. All right, this time the UR candidates are 4 and 2, and there are your diagonal bi-value cells, and there are your diagonal cells with extra candidates. So let's check both rows and both columns for candidates 4 and 2. And we see in row 8 there's a 2 there, and in row 9 there's a 2 there, and in column 3 we've got a 2 there, and in column 4 we have a 2 there. So candidate 4 does not appear anywhere else outside those 4 cells in both rows and both columns. Therefore, there is an X-wing on candidate 4. And we know from the type 6 rule that these two 4s must be false. So you can immediately solve these two 4s as the solutions to those two diagonal cells. All right, next one. All right, here the UR candidates are 1 and 8, and there's your diagonal bi-value cells, and here are your 2 cells with extra candidates. And the 1 and the 8 appear in all 4 of those cells. So we want to check both rows and both columns containing that rectangle for candidates 1 and 8. And in row 1 we have an 8, and another 8, and in row 2 we have an 8 and an 8, and as you can probably guess, in column 2 we've got some 8s, and in column 6 we have 2 8s, and there are no 1s. So that means there is an X-wing on candidate 1. And so the 1s in the cells with extra candidates have to be false, so you can immediately solve these 2 blue 1s for candidate 1 in those 2 cells. Now don't forget, if there was a candidate 1 in any of those 2 rows and 2 columns, like if there was a 1 here or if there was a 1 here, this is not going to work. Only one of those 2 UR candidates can appear outside the 4 cells in those 4 houses, and the other one cannot appear. And that one, the one that does not appear, is the solution to the 2 bi-value cells like that. All right, let's do one more. Okay, here the UR candidates are 7 and 5, and there's your rectangle, 2 diagonal bi-value cells, and 2 diagonal cells with extra candidates. So now let's look in the 2 rows and the 2 columns for 7 and 5, and we see we've got a 7 in row 5, and we've got a couple of 7s in row 9. And then in column 7, we've got a 7, and in column 8, we have a 7, and there are no 5s. So you should know by now that there's an X-wing on candidate 5 and that you can immediately solve these 2 cells for 5. All right, so that's type 6. Let's take a look at type 3. Okay, folks, at last we come to type 3. A UR type 3 is a little different from all the others we have been studying. It combines the UR principles with those of a locked or a naked subset that I briefly touched upon in my terminology video and covered a little more extensively in videos number 8 and number 9 on pairs and triplets. So I hope you have watched all of those lessons, which will give you a head start here. What we are looking for is a UR with 2 non-diagonal cells containing extra candidates like you see here in this diagram. Since we know that one of those extra candidates must be placed to avoid the forbidden UR pattern, we can treat both of the cells with extra candidates as one virtual cell containing only the extra candidates, and then try to build a naked subset that can be used to make eliminations. This will be feasible for pairs, triplets, and quads. Anything higher than that is improbable. So let's just focus on those 3 subsets: pairs, triplets, and quads. So what we do in a type 3 is ignore the UR candidates and focus on the additional candidates. Here in this diagram, the UR candidates are 1 and 3, and we see in the 2 UR cells in row 3 that the additional candidates are 2 and 7. It doesn't matter that the 2 is repeated. Now, either the 2 or the 7 has to be true in one of those cells, or we would have the forbidden pattern. So we can look at these two cells as one cell containing only 2 and 7. And now we look at the cell in row 3, column 1, and see that it also contains only 2 and 7. So these three cells become a virtual naked pair, which further means that we can eliminate candidates 2 and 7 from all other cells in that house, which in this diagram is row 3. So that means that this 2 is false, and this 7 is false, this 7 is false, that 2 is false, and that 7 is false. And you can eliminate all of those candidates that are marked red because of the virtual naked pair. All right, let's look at another one. All right, here in this diagram, the UR candidates are 7 and 6, and we have two non-diagonal cells up in row 1 that contain extra candidates, these two cells. But this time there are 3 additional candidates, 2, 5, and 9. So now we have to try to build a triple. So we look at row 1, column 1, and there's a 2 and a 5 and a 9 in there. And in row 1, column 8, there's a 2 and a 9. So that is a triple because the 2 green cells act as one cell containing only 2, 5, and 9 because we know one of those candidates must be true in there. So that means we can eliminate every other candidate 2, 5, and 9 from row 1. And so we've got a 5, and we've got a 2 and a 5, and a 2 and a 9, and a 5. All those candidates will be false because those 4 green cells act as a naked triple. All right, let's do one more before we get to the real puzzles. All right, here in this diagram, the UR candidates are 2 and 5, and we've got 2 non-diagonal cells that contain extra candidates here and here. And the additional candidates this time are 1 and 3. So we can look at that as a virtual cell containing only 1 and 3. And then we see there's another cell containing only 1 and 3 right here. So now we've got a naked pair. But this time that naked pair is locked because it lies in 2 houses at the same time. It lies in block 4 and it lies in row 6. So that means that naked pair can act as a locked pair and can eliminate all other candidates 1 and 3 from both of those houses. So that means you can eliminate this 1 and this 1 and this 3 and this 1 and this 3 and this 1 and this 3, and then in the row you can eliminate that 3, that 1, that 3, that 1, and that 3. So because that naked pair lies in 2 houses, the eliminations can apply to both houses. All right, let's look at some real examples and some real puzzles. Okay, here in this puzzle, the UR candidates are 4 and 5, and there's your rectangle. And we've got 2 non-diagonal cells with extra candidates here and here. And those extra candidates are 1 and 6, so we can look at those 2 green cells as one cell containing only the 1 and the 6. And we look in row 7, and there's another cell that contains only 1 and 6. And so together those cells form a naked pair. So now we look in the rest of row 7 to see if there are other candidates 1 and 6 to be eliminated, and there's one here and one here, and that's it. So you can eliminate those 2 candidates as being false. All right, next one. All right, here the UR candidates are 4 and 7, and there's your rectangle. And we've got 2 non-diagonal cells with extra candidates, and they lie here and here. And those extra candidates are 8 and 3. So that can be viewed as a virtual cell containing only 8 and 3. And so now we try to find some other cells in that column that will form a subset. And we see up here there's a 1 and 8 and a 3. And here there's a 1 and 8 and a 3. So those 4 cells form a naked triple. So now we look in the rest of that column for other 1s, 8s, and 3s, and we see there's a 1, an 8, and a 3 in this cell, and they can all be eliminated as false. All right, next. All right, this time the UR candidates are 4 and 3, and there's your rectangle, and we've got 2 non-diagonal cells with extra candidates. And those extra candidates are 8 and 6. So we can look at that as one cell containing only the 8 and 6. And we look in the rest of that column and we see there's another cell with only an 8 and a 6. So those three cells together form a naked pair, but they lie in two houses at the same time. They lie in block 4 and in column 1. So that means we can eliminate all other instances of candidate 8 and 6 from both the block and the column. So in the column, we've got a 6 here, and in the block, we've got a 6, and a 6, and there are no 8s, but you can eliminate all 4 of those candidate 6s because of that locked pair. Okay, let's do one more. All right, this time the UR candidates are 8 and 3, and there's your rectangle, and we've got two non-diagonal cells with extra candidates, here and here, and the extra candidates this time are 6, 2, and 7. So that's 3 candidates, and now we need to try to create a subset. So starting with 2, 6, and 7, we see we've got a 7 and a 6 here, so that's almost a triple. But now if we add candidate 4, we can make a quad. If we add that 4 and that 7 and that 4, 2, and 6, we've got 2, 4, 6, 7 as a naked quad. So let's mark those cells. So those 5 cells create a naked quad. So we can remove 2, 4, 6, and 7 from any other cell in that row, and we see here we've got a 2, a 6, and a 7. So those 3 candidates are false, and that was a naked quad created by the virtual cell in block 6. So there you have it. Those are unique rectangles. Types 1, 2, 4, and 7 come up all the time, and I'm sure you will find them to be very helpful, especially when you are stuck in a difficult position. The other 3, types 3, 5, and 6, are not as common, but you should still try to always remember how they work in case you ever stumble upon one. All right, let's go back outside and finish up for today. Thanks for watching. There will be an adjunct to this tutorial, video number 21A, where we will look at many additional examples of all the different types of URs we have covered, along with other insights and tips that may pop up along the way. So please take a look at that when you get a chance. In the next main video, we will examine the consequences of a somewhat rare situation called a bug plus 1, and that will be video number 22. Whenever you find a bug plus 1 and solve it, there will always be nothing but singles left, and the puzzle will be unlocked. So it is well worth understanding how to identify them. And I hope to see you for that lesson. In the meantime, be well and be happy.